my keynote address, which is a great honor for me. Let me start with the first slide, which is the verse from Holy Quran, in which Allah subhanahu wa ta'ala reveals that every living thing is made from water. So this is the ultimate information. But some scientists also have put their views in it, and life is considered as a organized water, starting from the DNA going to the mature life, living thing. Then Pasuria gave this equation, which shows that yield will be zero if the water transpired is zero. I start with the definition of arid climates according to FAO. As you know that arid environments are extremely diverse in nature, but there is a one common factor, which is the aridity in all regions. Aridity is usually expressed as the function of rainfall and temperature. And the aridity index is precipitation divided by evapotranspiration, potential evapotranspiration. The levels of aridity, one is the zone which is called hyper-arid zone, where the index is 0.03. There is rare vegetation, and true nomadic pastoralism is practiced there. Then the arid zone, which is characterized by pastoralism, but there is no farming except with irrigation. The next zone is semi-arid zone, which can support rain-fed agriculture without irrigation, but irrigation will help to increase yield manifold. Now, this is the summary according to the World Atlas of Desertification. Semi-arid regions have this index between 0.2 to 0.5, and the annual rainfall is 800 millimeter in summer and 500 millimeter in winter regimes. Arid areas, the index is between 0.05 to 0.2, with the mean annual precipitation of 200 millimeter. In the hyper environments, the rainfall is very little with no seasonal regime. I'll show you some maps of the arid areas. This maps shows the tropical drylands and non-tropical drylands. Next map is quite important because it differentiates between the physical water scarcity areas and economic scarcity areas. I hope you know the definitions of these. Then I'm try to put in hunger map, which is the old one, to see if there is any relationship between the hunger and the aridity. To be honest, I didn't find much relationship. Arid environments imply restricted water availability, which impacts all types of life. Another important factor which is going to affect the water availability patterns, that is climate change. In Pakistan, we have witnessed very high rainfall and unprecedented flash floods in the arid areas of Pakistan. Then this availability will change the glacier reservoirs, which will retreat in 50 years. This is the old data. And the flow will decrease by 30 to 40%. The seasonal flow patterns of rivers will also change. The Planning Commission of Pakistan has predicted that will be a big gap between the surface water demand and supplies in the next few years. Also, the net irrigation requirements will increase by 6 to 7% in Pakistan. The World Commission on Water has predicted that about half of the world's population will face severe water stress by 2025. And there may be many conflicts between the nations due to water stress, especially between South Asia, Middle East, and North Africa. So this figure shows the way we are mining using the groundwater resources. There is overexploitation, and we are mining 100% of the water available in some areas, different regions of the world. Now, arid environments may be accompanied by different factors which affect yields, like salinity, different patterns of rainfall, temperature regimes, and socioeconomic characteristics. I think now we should discuss the possibilities of mitigating the water shortages under different conditions. One possibility is that we select and fit plants, various crop species, varieties, shrubs, trees, and even animals which are resilient to drought. This slide shows some examples of drought-tolerant plants which grow naturally in different parts of the world. There are many other plants too, like mesquite and acacia and plesiops, etc., which can be grown under these dry, hard conditions without much yield losses. You see, this is a field which is irrigated in the arid areas and is highly saline. But the farmer has tried to grow wheat in this. You can imagine how much wheat he's going to get from it. We have tried to make this land productive by growing Atriplex amnicola and some trees of Eucalyptus camaldulensis. There is also natural grass underneath, and sheep and goat are being raised on this land, which is a successful experience. Now, using climate change impact models, we can adjust our planting times and densities, use different sowing methods, change cropping patterns and cropping intensity, and try to use efficient irrigation schedules. Also, an important intervention could be to develop varieties of crops, maybe of animals, which can successfully handle the situation. Short duration crops, high temperature tolerant crops, crops resistant to different abiotic and biotic stresses. And we should try to decrease lag and increase log period. We have to increase the base temperature of these varieties. This is an approach. If we are successful in the future, we can handle the problems of water shortage. Another approach is to save and conserve available water resources, store in large and small and medium dams, field tanks, tobas, and subsoil, and minimize the wastage in irrigation system and cropping fields. An important example of wastage is in Pakistan. We lose almost 50% of water during conveyance from rivers to the field. And then there are losses in the application losses in the fields also. We can use different moisture conservation practices and use high efficiency techniques for irrigation. Recently, one of my students in Mr. Khalil Rahman, working in Dubai, has tried subsoil irrigation of rice crop, and you can see the amount of water you can save by adopting sub-irrigation as against the conventional and traditional method of cultivation. I'm not sure of the differences in the cost of this method. Coming towards the conclusion, the punchline in all this is that we should aim at maximum yield per unit of water applied, and the farmer has to play the pivotal role in this case. For getting maximum yield per unit of water applied, we have to apply all inputs in optimum manner, right amount, right time, right method, and synchronize it with water availability from rainfall and irrigation. Now, I'm showing this figure as evidence. Then in major wheat growing areas of Pakistan and other world like China, Mediterranean, North America, Southeast Australia, the difference in the yield obtained with the same amount of rainfall and evapotranspiration is tremendous. You can say about 4 to 5 times in many cases. A living example is the difference of yield obtained in Egypt, that is about 6.5 tons per hectare of wheat, as against Pakistan, where we get 2.5 tons per hectare. Thus, the message is that while we are worrying about increasing and conserving the water resources and fight the climate changes, we must try to get maximum yield per acre with the resources which are available to us. Thank you very much. Assalamu alaikum.